Cliff notes.
Let me pull it up. Oh, this stuff's good. Hot. Alright, no, I know, we need a review. So, yes, because I know I do. I'm not stupid. I think I am, but I'm not. Alright. All I'm doing is second page, or technically it's the first page, the back part, and it has this bullshit right here, and that's what we're talking about. They're going to, that's what my mom told me as a kid, but they haven't yet. So, angle pairs formed by transversal. Yeah, I do. I'm proving it wrong. Alright, I just want to review. We have alternate interior angles, which is on the inside. Pause. I got your back. You ready for this? I figured out transversal for you. I did.
See it.
I tried my best because it was like a hard one. I promise you, it's hard. Yeah, get. I need at least one of your ears, out of respect.
Yeah.
I leave one. I leave the one towards you.
We'll see. We'll see how you do on the test, and then I'll decide for headphones. You need to be. I'm gonna get a box, like a little. I have one. I have a little like
Miss, do you ever find my quiz?
No, you didn't finish it, so you need to come in. That's why it's back there.
Oh, I need to come in on Friday, yeah.
All right.
I don't need to.
Don't do that.
I'll write that down.
What? Okay, so Vanessa yesterday asked me, she's like, okay, transversal. And I'm like, all right, Vanessa, I just know it's called a transversal. So here's the definition of a transversal. It is a line that crosses at least two other lines. And I told you guys yesterday that your transversals kind of go in the same, you have your two lines that are going the somewhat same direction. Your transversal kind of comes across as like, ah! It's like you guys have played the Fruit Ninja, right? Where just like you're chopping up fruit. Your Fruit Ninja, you are the transversal. Oh! So that is the definition of a transversal. Now, if we were going to take just a portion of the word, your transverse, or what it means to transverse, it means extending across something. So when I was thinking, I was like, okay, that's a great definition word, but I'm like, how can I actually like put that into like real life? Like, what does transverse mean? And it says extending across something, and I was thinking, okay, extending across something. That's a bridge. It's going from place one to place two. It's extending across. Typically, you see bridges. I could be wrong. You see bridges over a body of water. So the San Francisco Bridge, the Manhattan Bridge, that's all kind of over a huge body of water. Okay, so hold on, you gotta wait for me because somehow the picture ended up way down here. So here's my picture of a lake with a bridge. So our lake has two lines, because your lake doesn't just keep going, it's not just like never ending. It's there, and then it stops here. So your lake is like your two lines that are going in somewhat the same direction. So if I were to draw my lines of my lake, still going in the somewhat same direction, those are my two lines. And then I take into account that the word transverse is to extend between or to cut across two lines. Here's my transversal. It is my bridge between two lines. I need to get from point A to point B. I don't want to fall in between. So if you take it out, you have a transversal. You have angles. 1, 2, 3, 4, 5, 6, 7, 8. And you have now created your definition of your angles, your alternate interior angles, your same side interior angles, your corresponding angles, and your alternate exterior angles. You've created it. Here's your bridge. Did you guys like the bridge was red? The lake is blue. So our lake is going in the somewhat same direction with a bridge over top. So your transversal is a bridge. Somewhat better idea? Okay. Holy, I was like, gotta do this. Okay, so our key concepts, reminding you, we have our angles, our alternate interior angles. That is talking about the inside, the shit in between your two lines going the somewhat same direction. So we're talking about your alternate interior means inside. Alternate means we're on alternating teams. We're not on the same one. So that means that they are opposite. So 4 and 6 are alternate interior angles, as well as 5 and 3. So if you were here yesterday, you got all this, but I think we need to review because now we're going to get into parallelisms. Same side interior. Same side interior still in between your somewhat two directions, same two lines, but inside, same side interior is talking about the same side of the transversal. They're both right next to each other. So our same side interior, we have 3 and 6. Those are on the same side. They're both on the left side of my transversal. And we also know that 4 and 5 are also same side interior because they're in between our two lines and they live on the left side of our transversal. Corresponding angles. So corresponding, I told you when in doubt, box it out. Perfect. Corresponding means they're in the same position of your box. So angle 1, I really hope you know directions of boxes. If you don't, I don't know. So angle 1 is in your top left. So 5 is in my top left. They are called corresponding angles because they're in the same position. And then I can keep going. So 4 is in the bottom left, 8 is in the bottom left. Those are corresponding. 2 and 6 are both in my top right side of my box. And then lastly, we have 3 and 7, who are my bottom left. And I told you the way that I did it is my thriller. They're all in the same position. My thriller arms just go to every angle. What could I do?
Collapse the lines under the right top of your toe.
Yes, that also works. Is if you were to take this line and bring it down, you could actually cut it, and 1 and 5 would be in the same position. 2 and 6 would be in the same position. 4 and 8, 3 and 7. I don't know what you want to call that, can smashing. We're smashing the line. You could can smash sideways. Okay, our last one is alternate exterior angles. So now we're not talking in between our two lines, we're talking about the outside of our two lines. We talked that alternate means opposite, so we're talking about our opposite outside angles. So that's when I go my, okay? So 2 and 8 are alternate exterior angles because they are opposite, and we're talking about the outside of our two lines. And 1 and 7 are alternate exterior angles. I'm out of breath. Okay, now we are starting on problem 3. Classifying an angle pair. So, it says, are angles 1 and 3 alternate interior angles, same side interior angles, corresponding angles, or alternate exterior angles? So we're talking about 1 and 3, so I'm going to come over here and I'm going to circle 1 and 3. So first off, because now we can cross out any types we know that 1 and 3 are not. So let's say the two things that I always think of if we're trying to decipher what they are is we have 2 sets of angles that are inside, and we have a set of angles that is outside. We have our interior, we have our exterior. So looking at 1 and 3, are they exterior angles? Are they both on the outside of our two lines? No. So we can cross out our exterior. Boom. Are they both inside my two lines? No. Who is not inside? 1. So we can cross out inside. We can cross out inside. Which therefore leaves that they are what? They are corresponding. Oh, wait, what did I say? Oh, are angle 1 and 3 on the same side of the transversal?
No.
Hold on, here's your transversal, guys.
Yeah.
Here's your bridge. Are 1 and 3 on,
Oh, yeah.
do I wave to them over here? Or do I wave to them over there? Are they both being waved to?
Yes.
Yes. Oh, sorry. Are they taking a test?
Yeah.
They're just jelly, they're not in here. Okay, so angle 1 and angle 3 are corresponding angles. Oh, hold on, sorry guys, I have to lower my voice, which means you need to be quiet. So let's verify that. Shh. Let's verify that because we're gonna, when in doubt, box it out. So here's my box, here's my other box. 1 is in my top left. Is 3 in my top left of my box?
No.
No. 3 is also in my top left of my box. So yes, they are corresponding. Yes, they are in the same position. Okay, number 2. It says are angles 2 and 4. Like I said, I always like going over and figure out what I'm talking about. Are angles 2 and 4 alternate interior angles, same side interior, corresponding or alternate exterior? So just like what we did before, I'm going to use this reference right here to help us. So again, we have things that are talking about inside, and we have things that are talking about outside.
Wait, 2 and 3 would be same side interior, right?
2 and 3?
Yeah.
Okay, so is 2 and 4, are they both on the outside? No, so like I said, all I'm doing is bringing myself up here so we can talk. So we know that they are not exterior. Are they inside?
Yeah.
Yes, so now we're down to one of these two. Now if they are inside, we need to know, are they in the same position? Are they the same side of the transversal? Or are they opposites of each other? They are opposites. So that would be alternate. It's the notes from yesterday. Like that. They're alternate interior angles. Okay. Oh, here's the perfect example for you guys, because I had someone say, draw, here's an obtuse angle, draw, or create, or construct, that's a better word, construct an angle bisector. And someone was like, what's an obtuse angle? So we're going to reference back, I feel bad whoever that was, but here we are, we're going to answer it for you. They shall say, remain nameless. Kind of like, he shall not be named, like Voldemort, but I totally just said his name, so I guess I'm like Harry Potter, I don't care. Voldemort, come at me, bro. You're already dead, but I don't care. Actually, you know what HP's coming back?
Yeah.
Harry Potter?
No.
Probably come down with the
Voldemort
balls.
should kick his ass.
Okay. I was really excited. I got my husband totally videotaped in the movie theater. He's that cool, you know. All right, so obtuse means what?
Wait.
An obtuse angle is what?
Greater than 90.
Greater than 90 degrees. A right angle is
90.
90, and acute is
Less than 90.
less than 90. So we have 125. That's obtuse. It is greater than 90. Hiram, what did you say for 3? It is right, because it is a 90 degrees. And 4? Acute. Because it's acute. Like, who doesn't like miniature things of normal things, like miniature horses? Hell of a lot cuter than a regular horse. Mini dogs, super cuter than regular dogs.
Oh, there's
Mini cats, super cute.
Okay, I'll give you that one.
They're super cute.
But if you notice,
However, big
smaller
cats
the
are
it is,
cute. Like big cats, like lions.
You notice that, like, regular chihuahua, less anterior.
So a right angle is 90.
A right angle is 90 degrees, and we always denote it with a square.
And acute is what?
Less than 90. Like, think about it. It's acute. Like, don't you like miniature things? Like, somehow mini nail polishes are a hell of a lot cuter than regular nail polishes? I don't know. Mini lipsticks are cuter than regular. I don't know why. I just love
She's
stuff.
crazy.
Look at me and my horse.
You know how to say her last name?
No, then you can have dogs.
Yeah.
All right. Thomas. Don't make me raise my voice. I'll get in trouble by Mr. Kern again. All right.
He said it, he said
You know
it.
you used to play ball, right?
Yeah.
That's why I call him Curry. He's Curry, Mr. Curry. He's Curry.
Basketball, dome. Okay. All right.
Good.
Okay, so our vocabulary word is talking about interior. Again, just reiterating what we know. The interiorness is in between two lines.
Stop.
So now we're actually going to get into the idea of parallel lines and their corresponding angles. So we're going to take into account our alternate exterior, our alternate interior, same side interior, and corresponding, and what the relationship they have when your angles are, when your lines are parallel. So they're no longer going somewhat on the same direction, now they are going the same direction. I didn't write anything. All right.
Because I enrolled in the league and then I was like, well,
Flip.
might as well start my schedule.
I want you to do a big bold star when the lines are parallel. So now we actually can figure out the relationship that they have because the lines are parallel. Are.
What's a pirate's favorite letter?
Me.
That's what you think, but it's actually the C.
Got it.
No.
Okay, so there's like 4 different proofs, and theorems. And instead of wanting you guys to write this out, I thought I was nice. So I want you guys to follow along. I want you guys to make direction and make understanding. So, hey, shush. Now, I want you guys to know for each one of these, we're going to talk about what they mean, like more in like layman's terms. So like very direct versus using the proof words. So for our first one, it says, if a transversal intersects 2 parallel lines. So now our lines are parallel. Our transversal is our bridge over our parallel lake. And with our bridge, so if a transversal intersects 2 parallel lines, corresponding angles are now congruent. And what does congruent mean? So corresponding angles are the same. So when in doubt, box it out. Now we know that when we're doubting, we can box it out. And we now know that those angles are, whoa! We now know that our angles are the same. So top left is in our top left are the same, top right and top right are the same, bottom left are the same, bottom right. Feels like I'm cupping something other than angles. But, you know. Alternate interior angles. So those are inside our parallel line. So here's a parallel line, here's this one, so I'm like in between them. Alternate means opposite. So our opposite angles inside of our parallel lines are the same angle. So alternate interior, I want to make sure we're talking about interior, right? Yes. Alternate interior angles are the same. And there's technically, we can find all the angles of our parallel lines and our transversal, because you guys now should know that there should be 8. And we can find all the angles using corresponding alternate same side interior, alternate interior, as well as vertical angles. So we know if they're kissy faces, those two shall be the same. And those two shall pass. Okay. Side or same side interior angles. This is the only different one that's outside of the box. Same side interior. Remember those on the same side of our transversal? Inside. So here's my parallel line. I'm sticking between. On the same side. Those are supplementary. And remember, I told you alphabet-wise. We either have 90 or we have 180. Is supplementary 90 or 180? 180. Because remember, S is further down the alphabet. So is 80 in a number line. Or not 80, 180. So same side interior. Same side and add to 180. That's only when when they are in between our two parallel lines will they add up to 180 on the same side of the transversal.
You should do your same side supplementary.
Oh, I don't even remember what I did.
Remember that?
I do, but I don't even know when I. Oh yeah, it was like same side as supplementary, same side.
Oh, yeah, you did, yeah.
Yeah, whatever. I knew I did it, but I don't
You
remember
did.
what.
That's what it was.
And then alternate exterior angles are congruent. So now those are outside of my parallel lines. They are opposites. Those are the same. So your alt, whoop, exterior, ext are the same. And remember, I already said it, but let's reiterate it. Your vertical angles. Those are your kissy faces. We have kissy faces, kissy faces, kissy faces, kissy faces. So we have, ultimately, you'll have 4 sets of kissy faces. And each one of your kissy faces shall be the same. Okay. Okay, you guys ready? I am. All right, now let's actually define. So it says, using the graphic organizer in the diagram to find each congruent angle. Congruent meaning the same. So 3-2, so if we look back up, it says theorem 3-2, corresponding angles theorem. So we want to find who is corresponding to angle 3. And when we're talking about corresponding, I say when in doubt, box it out. So angle 3 is in our bottom left portion of our box. Bottom left.
Right.
If we brought this down, angle 3 would be on top of, oop, dirty, angle 1. So angle 3 is congruent to angle 1. That's where we use our little, remember, this means congruent, that means the same, that means that they are equal. So if angle 3 was 50, angle 1 would be 50. If angle 3 was 100, angle 1 would be 100.
That symbol means
Yep,
congruent?
this means congruent, because equal, what is this right here? Equal sign. And the reason why we have this little squiggle on top is because that's the symbol for similar, which if we took away equal, then we could talk about similar figures, but you're not going to, that would be the next block. Okay, now I'm going to erase my box it out. Now let's talk about theorem 3-1. 3-1 is alternate interior angles. Alternate interior angles are inside your parallel lines and they are opposite. And it gives us angle 3. So who is opposite of angle 3 and on the other side? 7. So angle 3 is congruent to angle 7. And then, let me guess, theorem 3-3 is alternate exterior angles. So now they are on the outside of our parallel line, and they're opposites and they are congruent. So we have angle 1. Let me erase this for a second. Angle 1. So who is opposite of angle 1? Pi. They create a diagonal line. All right. So identifying congruent angles. So I'm going to be 100% honest. When it actually comes to the assignment and when you are identifying congruent angles, you are not really going to be stepping this out. I know it's kind of like, you know how we were talking about proofs and how you use subtraction property of equality. Not on my time. When we use subtraction property of equality, or we use the transitive property, or we use substitution properties, those are all common sense things. And that's why proofs are so hard, because you just do those things instead of thinking, well, what allows me to do them? It's kind of the same idea with alternate exterior, alternate interior, blah, 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 blah. We're not actually, when you come to the assignment, I'm not going to be like, well, how'd you know that? I think at one point you now need to understand who's congruent, and you can get you that way using vertical angles, same side interior, alternate exterior. Technically you can use all 4, technically with vertical angles that would be 5. You could use all 5, you could use 2. It just kind of depends, and I don't want you to think you have to go in the order I say you do. So this is me just talking about it in a steppy way, like explaining why the hell I'm doing it. But when it comes to the assignment, you don't have to sit there and explain yourself. I think as long as you tell me what angles, you obviously get the math. So it says, can you always find the measure of 8 angles given when 2 lines are parallel and cut by transversal? Explain. Yes, you can. Because as long as you know one, we can use vertical angles, same side interior, alternate exterior, alternate interior, and same side. So we have all these different tools in our toolbox to use. So it says, yes, because angle 1 is congruent to 55 by vertical angle theorem. It says that the measure of angle 5. I'm following this for a second. We know that the measure of angle 1 is 55 degrees because of vertical angle theorem. So I'm just showing that those are vertical angles. So I went and wrote that. Now they're giving us an explanation. And then it says we know that the measure of angle 5 is equal to 55 by corresponding angles. So angle 5 is in our, remember, when in doubt, box it out. Angle 1 and angle 5 are both in my top left position. If I slid this over, 1 would be on top of 5. So therefore, 5 must be 55 degrees. And it kind of says that there, but I know sometimes reading directions is extremely hard to do. So I just read it for you. So it says now we're going to write a statement on how we can figure out angle 7, angle 5, yada, yada, yada. So the measure of angle 7 is equal to 55. So can I erase this real quick and get rid of my box it out? Okay. Oh, that didn't work. Okay, what are we doing here? Okay. So angle 1 is 55 degrees. Angle 5 is 55 degrees. I'm scratching it out. It says that the measure of angle 7 is 55 degrees. What is the relationship? We can look at it 2 ways. What is the relationship right off the bat between 5 and 7? No, 5 and 7.
Vertical angle?
They're vertical angles. They're kissy faces. I'm 5. You're 7. So we're kissy faces. They are vertical angles. They are across each other. That is one way we could say that. This is why it stinks. Or, what can you tell me about 55 in this box? 1, 2, 55, and 4. And 5, 6, 7, and 8. They're in the same position. So the reason why we know 7 is 55 is vertical angles, corresponding angles. Now what can you tell me about the relationship between angle 1 and 7? Alternate exterior angles. They are opposite of each other. Do you see that? We could have done 3 different things to get there. So I'm just going to write down all 3. They're corresponding. That's one way. Alternate exterior or vertical. Vert is vertical. Wow, that's a lot of options.
What's the second one?
Alternate exterior, alt ext. And we know that the measure of angle 5 is equal to the measure of angle 7. What is the relationship more specifically between 5 and 7? Which one of these are 5 and 7? Here's 5, here's 7. Nope. Are they corresponding? Are they in the same position? Last I checked, angle 5 is on top. He's a topper. Angle 7 is on bottom. So they are vertical. Kissy faces. So the reason why we know that 5 and 7 are equal is because they are vertical angles. I know. I wanted to hear other people. Measure of angle 5 is equal to 55. Okay, here's a proofy wise. Measure of angle 7 is equal to 55. The measure of angle 5 is equal to the measure of angle 7. What's happening here? Why can I take out 7 and get that the measure of angle 5 is equal to 55? What property allows me to get rid of 7?
Transit.
the transitive property. So by the transitive property, I can get rid of the stupid person that was being repeated. I hate 7. Worst number in the number line. I don't know. I really do. I don't like 7. So I got rid of them.
What step Dr. you?
Oh no, I'm just kidding. So then it says the measure of angle 5 is equal to 55. So now we're back to 5. We're right here. And it took that the measure of angle 5 is 55, and then it found out that the measure of angle 2 was 125. Woo! How would we understand that? How would we know that 55 and the measure of angle 2 would be 125?
Same side.
What does same side interior tell you?
Same side is supplementary.
Same side is supplementary. Same side is supplementary. So that means that my angle 5 and angle 2 have to add up to? What is
180.
supplementary?
180.
180. So 55 plus 125 does add up to 180. So we know that the measure of angle 2 is 125 because of same side interior. Now, it says, now it says that the measure of angle 4 is 125. So we just left off on 2. How do we know that he's 125? How do we know that angle 4 is 125? What's the relationship between 2 and 4?
Vertical angles.
They are vertical angles. They are kissing themselves. So measure of angle 4 is 125 because they are vertical angles. And then our last thing. It says the measure of angle 6 and the measure of angle 8 are both 125. So they're saying the measure of 6 is 125 and the measure of 8 is 125. Well, they are vertical, but what could you tell me if we looked at just 6 individually? What is the relationship we can figure out and how we can figure out that 6 is 125? Corresponding angles. Who is 6 corresponding to?
8.
2.
Well, no, 2, yeah.
2. So 2 and 6 are corresponding. So that's how we were able to get over and tell you that 6 is 125. How could we figure out that 8 is 125? Just looking at 8 alone.
4.
We don't know. Looking
Because
at it
the
alone.
vertical angle to 6.
We don't. Looking at 8 alone.
It's
Don't
just 4.
reference a 6.
Corresponding with 4.
It's corresponding with 4. So the reason why we know that the measure of angle 6 and the measure of angle 8 are both 125 is they're in the same position. I literally just went, put them in the same spot. So it's corresponding.
This is like the worst. It's easy, but it's just there's too much writing.
If you just get past A, it gets better. Well, GFC is a clusterfuck, if I could say. All right. On to the next one. I'm not going to be asking you guys to be doing that kind of stuff. I'm going to just have you find it. So we're going to be proving angle relationships. So just talking about, I'm giving you something, and now we have to prove things. They give us the reasonings. We just have to come up with the statements of what angles are equal to each other and show on to show form. So it says reason 1 is it's given to us. So what do we know? What's a statement that's truly been?
A is parallel B.
Perfect. A is parallel to B. That's fine. I just did it because that's what they have. And then our next reasoning is saying if 2 lines are parallel, if 2 lines are parallel, then corresponding angles are congruent. Out of 1, 5, 8, and 7, who are corresponding?
5, 7.
5 and 7, are those in the same position? Last I checked, if one in doubt, I boxed it out.
5 and 8.
Or what 5?
5 and 8 are in the same box. 1 and 7 are not in the same position.
1 and 5.
1 and 5, they are both in my top left of my box. So angle 1 is congruent to angle 5. Our next reasoning is congruent angles have equal measure. So instead of saying they are congruent, we now want to say that they are just truly equal. Angle 1 is equal to angle 5. Then it says vertical angles are congruent. Where do we have any vertical angles present?
Yeah.
5 and 7. They are on the same box. They are looking at each other. They're kissing each other if they could. So that means that angle 5 and angle 7. They are vertical angles. Congruent angles. Oh, you know what? Sorry. Can I do something? I read it wrong. It doesn't just say vertical angles. It says vertical angles are congruent. So that should be a congruent symbol there, not an and. My fault. Sorry, guys. I thought it was just asking for the vertical angles. It's wanting that vertical angles are congruent. So that's why I went and replaced it with a congruent symbol. Now, it says congruent angles have equal measure. So just like what we did before, how are we going to change angle 5 is congruent to angle 7 to show that they have equal measure? What?
Just go to where we are right now.
No, I don't want to use a transitive property. All it says is congruent angles have equal measure. So we used congruent angles have equal measure. What did we replace? Perfect. All we would do is, instead of saying that they are congruent, we would now say that they are truly equal. Now we're going to use the transitive property. Let's look at our blue. I'm going to erase this and make it a blue. Blue is my favorite color, so I'd rather be.
What?
Are you arguing with that?
Yeah. I
Red's
like
better.
like red.
Blue's pretty.
Red's prettier.
Okay, so we're going to focus on our two blues. Angle 1 is equal to angle 5, and angle 5 is equal to angle 7. So it's telling us right off the bat we're going to use the transitive property. The transitive property does what?
It allows you to eliminate the middleman.
It allows you to eliminate the middleman. So who's my middleman? Who gets repeated? 5. So I can cross out my 5, cross out my 5. Now what can you tell me? What about 1 and 7?
They're congruent.
Angle 1 is congruent to angle 7. And then angles, oh, that should be an equals. Hold on, I'm such a horrible person. I'm sorry. That's an equals.
I said.
Oh, I'm sorry.
Wait, why would it be an equal? if it-
Because we're talking about equals.
But it shows the.
Okay, because the transitive property of congruence. That's the name of it.
Oh, okay.
Because if you look at the next one, it says angles with equal measures are congruent. So now we have that they're equal. Now we're saying angles with equal measures are congruent. So we can change that equal sign to a congruent.
That last one you're writing, that's number 7, right?
Yes, I just wrote really huge.
She was so serious. I'll be serious. Angle 5.
All right.
It's just 5. Hold on, I know you guys are ready. Oh, that. You were on the wrong page. You can see it right there. He's doing this long part. Angle 1 is equal to angle 5 to make cross out. No sleeping in class, Miss K.
On what grounds?
On yours.
Leave one eye open.
I'm gonna say that next. I'm gonna put my head down and be like, what grounds, Miss K? That you said.
Just stay there
What?
for 15 minutes.
Oh, sorry, what's happening?
What?
All right.
Yeah, Monday you be here.
Don't do that. All right, I'm disregarding that problem. I'm over it. I don't care about it. Disregard, like, disregard, like, yeah. So, like, regarding these, like, we have to talk regarding, like, my donuts, and I'm like, who do you talk to regarding your donut? And I'm gonna say, I'm gonna disregard that, I'm gonna ignore the fact that you got donuts. Okay. Yeah, sure. I'm exhausted. So, using algebra to find an angle measure. So we're going to use algebra to find an angle measure. It says in the figure at the right, what are the values of x and y? So if we know that these are parallel, very last page. I said skip it, but obviously I need to repeat myself 19 times. Yeah, okay, one more time, it's fine. Okay, it says using algebra you can find an angle measure as long as your figure has parallel lines in it. We are talking about a trapezoid, if you didn't know that. Well, now you do, and we'll talk more about it later. But a trapezoid, it has two parallel lines, its top and bottom are parallel to each other. And technically we have two transversals. We have a transversal connecting this line, and we have a transversal connecting the other direction. I'm going to talk about one first. I don't want to get too, hey Craig. So, when we look at this, disregard that we've created a trapezoid. If you look at this figure, I'm going to redraw it. It looks like this. And we have a 2x positioned right here. And we have an x minus 12 right there. What is the relationship between 2x and x minus 12? Or first off, are they inside or outside or neither? They're inside. So the two inside we have is alternate interior or same side interior. They are same side interior because they're the same side of the transversal. 2x, x plus 12. They're on the same spot. Here we are. So when they are on the same side interior, same side is supplementary. Same side is supplementary.
So it's same side and
It's called same side interior.
oh, okay.
So it's like a mouthful. So I'm gonna you guys have a whole page. We're gonna just rewrite. You can just disregard this right here. So we know that 2x and x minus 12 is same side interior. And same side interior is supplementary. It's the only one that is different than alternate exterior, alternate interior, corresponding, because those are all congruent. Same side interior is supplementary. Supplementary means adds to 180. So we're going to add to 180 degrees. So same side interior adds to 180. So when they are corresponding, or not corresponding, sorry, when they are congruent, they are equal. Because remember, congruent means same. It means equal. Interior means that they add to 180. So two things have to add together. So if I had 3 burgers, I need 97 more to add to 100. So these two things have to add to 180. So here's my one thing. I'm picking up my one thing. My 2x. Picking up my second thing. X minus 12. Have to add to 180. You can do that in the studio. When you get there, let me know. Okay, so all I did is, since they are the same side, we know that those two things added together must add to 180 degrees. So 2x plus x minus 12 equals 180. You've now created an expression, sorry, even more than an expression, you've now created an equation, and you can solve it. So we have 2x plus x minus 12 equals 180. What's my first step? What is the first thing I should do?
Combine like terms.
Combine like terms. I have a 2x and I have another x. I had 2 ex-boyfriends in Texas, and now I have 1 ex-boyfriend in Arizona. So how many x's do I have total?
3.
2.
All my x's live in Texas, remember? Now, we didn't use anything with that negative 12, so I'm going to bring them down. And that equals 180.
Yes. Add 12.
Hold on. Are we good there? Are you guys good that I combine my like terms to get 3x minus 12 equals 180?
Add 12.
That's a Pythagorean triple if you guys wanted to know. So we have 3x minus 12 equals 180. Now, it's a two-step equation. I want to cover my x. That negative 12 is where I want to start. So I'm going to add 12 on both sides.
192.
So we get 3x equals 180 plus 12 is 192.
So then we divide.
Now, how do I get x by itself?
Divide by 3.
Perfect. Divide by 3. That cancels out. We get x equals
64.
3 can go into 19 6 times with 1 left over. 1 is bring down to 12, and 3 can go into 12 or 10. So our x value is 64. Now we're going to plug it in. We're going to verify this. So 2 times 64.
It's 128.
Yep, 128. So it's 128 degrees. And 64 minus 12 is 52. Is that true? Is 128 plus 52 180? 8 plus 2 is 10. Carry the 1, so we have a 0. 5 plus 2 plus 1 more. 5, 6, 7, 8. Whoop! 80. Bring down your 1. 180. Pocket change.
Okay, so you added 128.
Yep, because remember, there's
180 is
same
not pocket
side
change.
interior. That means that they should add to 180. You can always check your work. You can always see if you add those together. If they come out to 180, you know that your answer is correct.
It's not. Hey, we know about that.
All right, can I erase X?
Yes.
Let's talk about Y. So here's our parallel. Whoa. I promise I can draw a line, I promise. Whoa, that still sucks. Here are my parallel lines, and now here's my other transversal. My other transversal is now representing my Y. Here's my parallel line. 3y is right here. Y plus 12 is 20.
Where'd you 12 from?
That guy. And then we have 3y, and then we have y plus 20. Again, are they on the same side of the transversal?
Yes.
Yes. So since they are on the same side of the transversal, they are same side interior. Can you get the gist of everything that this is going to happen? Anytime you're looking at two figures, they're all in their parallel. They're always going to be same side. Is supplementary. So we have same side interior. And we know, by now, you should know that they are,
Supplementary.
which adds to?
180.
Okay. They don't add to be the same, they add to be 180. So now I'm going to take my stuff. They should add, what?
You mean same side or same
They're the same thing. I'm like seeing dots, it's really weird. Same side, interior. They should add to be equal 180. So I'm going to take my stuff, I'm going to bring my 3y plus my y plus 20 and bring it down. I think at this point you guys can solve an equation.
Very done. Okay, I need that. 40.
Why do I keep giving us doing the lessons?
I did it on the white.
What'd you get?
She's a mean team.
Was, did
She comes in.
you hear that? Did you hear that pass test at home?
I'm fine with the transition, but oh, I'm seeing dots like right there. Perfect. All right, when you solve for y, what do you get y to be? 40. And then go plug it back in and tell me what your degrees are so you know if your angles are truly going to add up to 1.